Good afternoon. Am I audible?
Yes, sir.
Okay, let's wait for a couple of minutes. Good afternoon, friends. Let us get started. I see very few people, so that's the effect of having done the quiz 3. Uh, so, well, their choice. Let me put up the presentation. Is the presentation visible?
Yes, sir, it is visible now.
Yeah. Okay. So we have been discussing about different software engineering processes, and of course, we have loosely grouped them under development and maintenance, but all processes are actually useful in both of these phases. Maybe they take different forms depending on the phase in which that process is being done. For example, the testing phase during development would focus more on unit testing, integration testing, and certain types of system testing, whereas in the maintenance phase it might look at some of the others, may not do a few but may want to do few more, and so on. So in terms of this, we have looked at certain debugging processes and a very major tool in software engineering, which is bug tracker or issue tracker, and just took glimpses of that, particularly open source Bugzilla. You can look at other as well. Now, today I will discuss about testing processes. We have been talking about this since almost the beginning of our course, because you cannot do any software, or you cannot develop anything, you cannot make anything useful unless you can test it well and expose as many errors as possible. Now, for software, testing is a process which is continual. It does not, we can say that, well, this is when the system has been tested to the desired extent, but at no point of time it's actually complete. So in terms of testing, the first that I would like to discuss is regression testing. It is a kind of testing which is performed on a state of a software which has certain features well tested already. So regression testing is for an existing software which has passed these tests. So you're repeating that. And why are you repeating that? Because we discussed during debugging and bug fixing that it is possible that when you fix a certain bug, or add a very maybe minor new feature, there may be earlier behavior which might break, which might regress. So it is important to ensure that in terms of fixing what was a bug, we do not introduce new bugs. So at least one indicator could be that everything that was passing earlier should also pass at this point of time. And naturally, regression testing is something which keeps on happening in all phases, at all levels of abstraction, both for development and maintenance. Any change in the software, check the regression. That's kind of the thumb rule. Beyond that, so we will talk about primarily the testing processes which are significant for development. Unit testing, we talked about it at stages. We have seen examples also. You all have started writing unit tests as well. Then talked about approaches to integration testing and system testing. That's what we want to cover today. Okay, so first the regression testing. So regression testing, regression, as a term, regression is kind of you regress when you go back to a earlier state or a less developed state. I mean, it is used in kind of mixed connotation. So in school, we have seen regression line, right? There was, if there are two variables, x and y, where x is independent and y is dependent on x, and if I say no, that the dependence is some kind of a linear dependence or approximable by linear dependence, linear relationship, then I need to find out what is that relationship. So ax plus by plus c is equal to 0. If that is the kind of relationship that x and y has, then from a set of data points, I want to estimate these values of a, b, and x. And what we do is we kind of treating a, b as kind of variables. We try to see how the changes in these coefficient values change the error. And that error is the amount of regression it is having from the estimated linear relationship and the observed relationship. And we want to minimize that amount of error or amount of regression. So that's the kind of basic essence. In regression testing, what we do is we rerun various functional and non-functional tests to ensure that whatever we have developed earlier, the tested the software, it still performs after a change. If it does not, then we would call that a regression has happened, the software has regressed. So typically, since it is to be repeated very frequently, in fact, just to give you a sense of how frequent it is, you have a daily task as a developer. Let's say when you join the company and you got a couple of bugs in the morning from your lead to fix. You fix them through the day. And at the end of the day, the changes that you have made in the code has to be checked in. We will talk about this check-in process in some more details under maintenance, but it is pretty much a regular development process. Also, you have fixed certain issues. There could be bugs, there could be new developments, and you need to make sure that the point at which you had started in the morning, you have not regressed from that, right? So you need to run the regression. Possibly, I mean, it might take through the night, and hope that you haven't broken anything. And if it is clean, only then your lead will allow you to check in your code, that is, make those changes available in the software being developed, so that others, your colleagues who are also working on that software, can actually as well see those changes, right? So it could be very, very frequently executing process. So most often it is an automated process. It needs, it needs a heavy amount of automation, possibly even might be a cron job. So it generates a report at the end which says it is clean, or it says that these are the test cases that have failed, and this was the expected golden, and this is what it has produced, and so on, right? So that's a basic regression testing. So for setting up a test suite for regression, we typically have two types of test cases. One, which are positive test cases. So where we expect the system to have a successful termination, a successful output, right? So you're doing a booking, you expect a positive test case, that the passenger data is all okay, the booking class is okay, booking category is okay, and you have a successful booking. But you also need to have negative test cases. The negative test cases or failure cases are required to check for different errors that you expect the system to throw, expect the system to demonstrate. So there could be four possibilities between these two types of test cases and two types of outcome for the execution. Naturally, it could be a positive test case could be successful, so we say it is a pass, or a negative test case could be unsuccessful, that is also a regression pass, because you expect the negative test case to fail, right? So if to be unsuccessful. Otherwise, if a negative test case is successful, then it is a regression failure, as well as if a positive test case is unsuccessful, then it is again a regression failure, right? So some people use the term true positive, true negative, false positive, false negative in these four quadrants. And if you have had glimpses in terms of some of the machine learning techniques, they will very regularly talk about different accuracy parameter. They will talk about what is the recall of your system, what is the precision of your system, which treats all these four values, true positive, true negative, false positive, false negative, as different quantum. But in terms of regression, grossly, we are interested to see how much has passed. So positive test cases must be successful, negative test cases must be unsuccessful. So a regression output will be typically the percentage of the number of pass cases divided by total number of cases. Right? So you want this to be 100% every time. Okay. So how do you approach regression testing? Now, certainly in general, the regression suite keeps on growing. Right? You are fixing more and more bugs, you are adding more and more features, so more and more test cases are getting added. And it often leads to a point where it is infeasible, in terms of your available resources, to run the entire regression all the time, right? So you could do some strategization for that. For example, when you know that there is a major change, or you are going to make a major version release, you might want to run the whole thing, right? That's use all test cases. But in specificity, you will often do a test selection for regression, that you will decide that, well, this is a subset of the regression test suite that I will run, and it is okay to do that to get the confidence. So these are some of the parameters that you might look at. It depends on the situation, of course. like test cases which have frequent defects, right? Which have come in multiple times, multiple issues have been reported. So you want to make sure, so that those are weak areas of your software. So those need to get tested. Functionalities which are more visible to the user. I mean, finally, what you want the least is customer end embarrassment, right? Test cases which verify core features of the product, that has to be sound. Test cases of functionalities which have undergone more and recent changes. So again, that's kind of indicator of weak areas or recent changes and so on. You would possibly like to run all integration and complex test cases to make sure things are not breaking at a higher level. Boundary value test cases, of course, and maybe then a random sample of successful and failure test cases. Now, it's not necessary that you are limited to this choice. Neither it is necessary that you will run all of these in your test selection, but these are some guidelines of how you select a suitable regression test suite for you. At times, your project lead will tell you that, okay, run this. There are 317 folders in the test suite. Run these 20 folders. So you'll set that in the testing script that run these 20 folders. Or in other cases, it might be the lead might leave it to your judgment to decide as to which test cases you should run. Naturally, prioritization is another strategy because even the selection may be a little too big. So even within the selection, you might want to prioritize depending on business impact, critical and frequently used functionalities. Like anything in general should be prioritized is what is beneficial for the subsequent version. So you're trying to kind of look at the future for your product. Or there could be version specific prioritization, which is beneficial for a particular version. And of course, in practice, what will happen, you will do a hybrid. You will do some test selection, some prioritization, and make your actual. But this is a very important step to decide on the regression test suite. As I said, it needs a heavy amount of automation. So it needs that besides your skills in programming languages like C++, Java, C, Python, you must have good skill in scripting so that you can write the regression automation scripts. You can understand the regression automation scripts, and there are a wide range of choices that exist depending on different situations, different type of software. So in Unix, Linux, you have shell script, bash, sed, awk, etc. I mean, for different purposes of regression scripting. On Windows, there are Windows scripts, as well as VBScript is very frequently used. Right. So if you're working on Windows, it's good to pick up VBScripts. In general, there are Perl. At one point of time dominated the entire scenario of scripting, because it's a very, very powerful language for scripting. All scripting languages are interpreted. That's their, I mean, you can change them at the execution time. They're interpreted while they're executed. And Perl is kind of the leader on that. But Perl did not have the other features of a software to be developed in it. So Perl never graduated to being a programming language in that sense. But Python has both. Python, so that's another reason that many people love Python. I love Python too, because you can do a fair amount of decent programming in Python, a decent amount of object-oriented programming in Python, as well as you can do a significant amount of efficient scripting in Python. Right. So these are languages to learn, languages to practice. I mean, at least even if you do not become a master, I would suggest that at different contexts, try to take a look, spend a couple of days playing around with the language. It's good fun. Besides that, there are different regression testing tools. During the assignments in the theory as well as laboratory, there were several questions in terms of GUI testing, which we did not include exclusively in your assignment for the shortage of time. But Selenium is a very popular tool. It's open source, it's free, and it's a portable framework for automating web applications. So I've given the links also. You can go there and check that out. So Selenium is a good tool to learn. Just try it out so that it can be used for variety of GUI testing. So the main, I should say the philosophy of GUI testing, or what is used in Selenium, is record and playback feature. That is certainly the GUI cannot be automated in the sense it has visual semantics, right? Because you get to see what is output, and based on that you click something and so on. So that needs a human being. So it does not look at automating that step, but what it does when you are trying to test a GUI with Selenium, you put the record on, and whatever actions you are doing on that software, it keeps on recording those actions. Now that recorded script can be played back. So which means that it's like doing a regression. So instead of having those input from a text file, which comes from the command line, or you read it as a file, you are getting those by a pseudo user who had once in the history did those actions, and you are just playing those actions back. Now, how does Selenium do that in terms of the monitor screen, capturing the mouse position, the mouse and keyboard events, and so on, are interesting topics to understand, but well, we do not have that much time. But this is the basic philosophy of Selenium, and you must understand that it's a record and playback tool for authoring functional test. And there are test scripting languages also in which you can do that, but it's a lot more difficult to do this. Selenium makes that IDE makes it much easier to do. Then there are other heavy duty, higher functionality commercial tools like UFT. Currently it's called UFT1. Earlier it was Quick Test Professional from HP. Now it is under Micro Focus. So that's a very strong tool to automate functional and regression test, which has intelligent test automation. Like it makes good guesses about the test cases that may be added, and on a wide variety of scale and platform it can be used. So is a rational functional tester from IBM. Variety of platforms, variety of software building tools. It works. So these are, when you are working in the company, don't get surprised if you hear about such tools, or maybe some other tools that you may be using. But Selenium being open source and free, and covering GUI testing, which is not easily scriptable, is a very, very popular tool that I would advise that at some point of time you just explore, have fun with it. Okay. Now, obviously, regression testing also runs in parallel with another concept called retesting. Now, regression testing and retesting are very close, but they are not the same. Retesting means that you are testing the functionality of the or bug again to ensure that the code is fixed. If it is not fixed, defect needs to be reopened. If it is fixed, the defect is closed. We talked about this in the debug. So this is retesting. This is not regression testing. Regression testing is just, blindly running the selected test cases, getting the output and matching with the golden and saying whether it pass or fail. So there are different ways that regression testing and retesting kind of are close but different. So these testing naturally needs manual intervention, because you may have to, when you fix a bug, it is quite possible that because of that your golden mean change, right? Because your functionality, fixing your bug is changing the functionality in some way or other. So it might change the golden. So who says that this changed golden has to be the new golden? That this is a new standard to follow. So it has to be a manual intervention. So retesting often is a manual intervention test. It is not. It cannot be automated. but regression testing continues to be a majorly automated stuff. Okay, so this is kind of the story of the regression test. Now, in terms of building the regression test suite, there are some examples in the later part of this presentation of you know some glimpses of regression test suites that have put, not the entire thing though, but some glimpses. So you can go through those. So it is for to repeat old tests and runs. So every test case has a golden, and possibly you will this folder structure is very important, because you can see that if you put all regression test suite flat into one folder, then things like test selection or prioritization and so on will become very difficult. So you need to again have a hierarchical structure of the test suite, kind of you can say classes, subclasses, kind of conceptually. You could actually make a generalization, specialization diagram of the test suite also, and organize the folder according to that. So there could be a folder in unit tests, which has all the unit tests, or could have subfolders saying that having every folder for every class that you unit test, and so on. There could be API or application tests. For example, several of the software that you built are to be used by others in developing their program. Those are called libraries, like the C++ standard library, or like C standard library, or the Qt graphics library, and so on. So you could be building a library. If you build a library, you have APIs. By API here, I generically does not necessarily mean function. It could be functions, it could be class interfaces, and so on. So there would be tests for checking those out. So they will go in a different folder, subfolders for their specializations and so on. Then there would be a variety of different kinds of tests, like directed tests. This is what I want to test. Like coverage, I want to increase the coverage. So this particular line I want to test. So I have this test case, not because functionally I got motivated to include it, but I saw that I feel this particular line in the code is very important, but it's not getting covered by others. So I write a test case specifically. I mean, backtracking from that point and finding out what inputs will work, I've written a directed test case. Directed test case could be also used for fault-based coverage and so on. Corner cases, boundary values, I would like to certainly write for them. Then whenever you have had failures in the software, whenever you had bugs or small new requirements, the customer may have sent you test cases. Customer cases must always be run, because you do not want to be embarrassed that the customer comes back and say, oh, I gave you this test case earlier, you fixed it, and now in your new fix, this test case is failing. So there could be a separate folder for that. You have multiple customers for your software. You may have separate folders for different customers and so on. Then you may have some random and huge tests just to check for the stress and all that. You may have performance tests to check out how you are doing time-wise, how you are doing resource-wise. Certain test cases will really drive the system to low memory. And you want to see that, well, you can still manage, you can recover with the decent messages and so on. Coverage tests for line coverage, function coverage, branch coverage, whatever kinds and so on. So there could be a variety of test cases, and there could be, for example, what is not listed here, certainly I missed out, is GUI tests would also be here. And then you have a folder structure. I mean, it's like this, you are looking for automation, right? So if your every test file has a different name, then it gets a lot more difficult to write the scripts. So what you try to do is you even a single test case is wrapped in a folder, and that folder name has a so you have a recursive traversal on your folder structure, starting from a specific root node, which is a subset of test suite that you want to run. And your automation script keeps on taking out the folders going in them. And when it finally does not get any folder, it will get a test case file with the golden, or maybe separately with the golden, but their names should be uniform. So that when you get that, your run script does not need further engineering. You take this and do that, and this is where you'll get the golden and so on. So some of the basic engineering tricks that you keep on doing, and then the regression test suite will have the run script, which I talked about in Python or Perl or other language. Regression suites for compilation will have makefile and so on and so forth. Right. So this is a basic structure of regression testing. Let me stop here once before I go to the rest and see if you have any questions.
Sir, what sort of other than the playback feature, what sort of advantages Selenium testing have over DOM testing? Because like in the thing we are making for the software lab, our group has a front end, web-based front end, which can be DOM tested, but we don't have time for that, unfortunately.
See, record and playback is in itself a very strong feature. That is, I should not just say that it is a feature. It is a philosophy on which Selenium is built, right? And you can use it in multiple ways. For example, you can use it in certain parts for test generation, right? You come to this point, and it knows what are the graphic elements available on that screen. So you can tell that, well, for these kind of elements, this is the range of values, or this is a set of options. This is the drop down. So it could actually take combinations of those and create test cases and automate that. Are you getting my point? It's not, but the core of it is record and playback, that you will do all this setting. You should not need to do all this setting every time. You can do a dump test for your software once, twice, but you cannot do it every day. You are keeping on fixing things, and you cannot do a dump test every day. I mean, you most of the time you will be testing only, not developing, right? So that is where it gets. So it is a test automation tool which has a primary focus on GUI. So record and playback becomes a major feature, which many other regression test tools will not have. Right. Does that answer your question, or you had more in it?
Though I mean, like Selenium, it works for many cases, but like I'm talking specifically about web pages for which the DOM is accessible. So if we test the DOM, isn't that a stronger guarantee than testing just what we see on the
Selenium
screen?
will allow you to do that as well. You are not excluding
so that's
that.
a part of Selenium as well.
Yeah. Selenium, that's what I'm saying, that Selenium gives you an access to automation. Right. So if you have a well-defined DOM, right, then what you have an abstraction for what you visually see, and you are relying on you are relying on the renderability of the browser to assume that if your DOM is correct, your rendering is correct, right?
Yeah, testing whether Chrome or Firefox works is kind of outside the scope of most projects.
Right. That's what I'm saying. So that is an easier part. So I talked about that another very easy but naive way of testing. You cut out your GUI layer from the rest of the software and have a model for interaction between the two. So that could
what
be
we were doing in our project.
Yeah, that could be mostly, when it is well defined, then it is a DOM. Say you are, for example, you are testing the viewability of PDF files. Right? It has a very strong DOM. The Acrobat has a very strong DOM. Right?
Yeah,
so
it is very complex as well.
It's very complex. That's why we all are. We all in the industry. Those who are in the industry are paid so much, because it's engineering is about handling complexity. Otherwise, at the basic level, it's too simple. It's common sense. It's handling complexity is the engineering. Right. So there are several places where you have DOM, and that's the reason that lot of GUI is modeled in terms of a separate data layer and separate visualization layer. Right?
The
Like,
MVC.
yes, so that's MVC. You know that I mean, I don't have time to get into all those architecture, but it's just beautiful that you have separated that out. So ensuring the backend feeds that data layer, backend feeds that your XML DOM is correct. If it is correct, then your overall testing of the GUI is not to the extent of testing it with the functionality. It is just testing it against the DOM. So you're separating these two. So your complexity of testing becomes additive instead of being multiplicative.
Exactly.
Right.
That's what I was saying.
So that is a strategy. You know, that's why, I mean, I said at the beginning that people think that I'm being asked to test. Oh my God, such a demotion is no. Testing, in my opinion,
Kind of harder than developing.
it's a lot harder than that. And finding out the right automation, correct automation, going to the extent of automated test generation, regressions, different kind of subsystems. And all this you are now talking is just in terms of the visual user interface. You are having so many different types of interfaces now. So how do you test for those? You know, it's a huge, I mean, just think of how Alexa was tested. And I do not know. I would love to know, but I'm not getting someone who knows the internals. But
I am pretty sure it's quite secret.
It could be secret, but you know, if you can get friends, like at one point of time, I was at that time I used to work for a company in New Jersey. NEC had a New Jersey office, so I was migrating. They have a software developed on Windows on Unix using X Windows graphics. And I was migrating. I was working on the migration of that onto Windows, and that was a time when higher order graphics like DirectX had just been launched. It did not get stabilized and so on. There was not much documentation and so on. So we were going through a lot of issues in doing that. How you do different equivalent operations in DirectX, because it's DirectX is conceptualized as a multimedia interface. It's just not graphics. It's just not graphics. It has audio, it has video, it has synchronization models and so on. So no documentation available. So fortunately, my classmate, who was our batch topper and PGM here, was at that time the MD of Microsoft India. So I called him, said, Amit, this is a problem. He said, I cannot give you those internals. So I will get you connected with a person and leave it out to you. So he got me connected. I started talking to that person. He always said, I cannot give you anything. But then as I gave him the problem, he used to send me internal documents without anything, just the text. And that's how I learned. And that's how I could use that, because there were a lot of APIs which were not even published. So, you know, their test cases worked pretty fine and my test cases were failing. So these kind of things you need to do when you go at the cutting edge, and you keep learning through different sources. But the basic point that I'm trying to drive is tools like Selenium are gold in terms of test automation, and that's a big challenge. You know, you regularly want to keep exploring and developing on those.
GUI testing is a big headache.
I will, I mean, towards the end in the last class, maybe if I get time, I will talk about a very different automation for knowledge transfer, which is one area that I work in. And we are working on some very interesting problems for how do you transfer knowledge from one developer to another without having a human intervention. How do you learn from the software itself and develop that knowledge? So, I mean, if we get time, I would like to talk about that, because I think that's where the real, challenges of software engineering lie. You know, it's not in terms of just making documents and so on. Okay, just to quickly cover up unit testing, you all know. So I would not. This is just for completeness. And we talked about test-driven development in that. I've given the basic test TDD flowchart. So the whole philosophy, just to remind you, is that you don't write the software or write the design and then write the tests. You do the other way. You write tests based on the specification, and always you try to target to meet a few tests, make those pass. If they pass, then you stop there. You don't keep on developing further. You take more test cases. If they fail, you fix them. So it is in several areas. This proves to be a good strategy. Now, I do not know if many companies use it at a very extensive level, but groups internally keep using that. One of the reasons that TDD is still not getting to be highly popular is the language support, which is in terms of unit. It's called a test unit. Java has a decent amount of support in JUnit. C++ has CPP unit, but it's somewhat broken. And the D language is emerging. If it gains ground, then this will become more popular. It's a nice philosophy, nice strategy, but in my view, not very scalable yet. So these are the unit testing you do. So the more important thing is you have tested the units. Now, how do you integrate? That is where a big challenge comes up. So there are typically 4 common sense strategies that you have, and that's it. People have not been able to design anything beyond these 4 strategies, which any of us, if we spend 1 hour time, you'll discover for yourself. One is what is called a Big Bang approach. That is, you have developed all the units, integrate all of them together, right? So that's called the Big Bang, because obviously, as we say, as we were just discussing, it gets a multiplicative complexity. You know, I mean, even if I have 10 units and if 2 of them have errors, then when I integrate all of them together, finding out which are the 2 units which have errors and what those are will be a exponentially difficult problem. So it's useful only for small systems like the booking system you did and so on. But normally that's not what you would be doing a lot. Another is bottom up, where you take the units at the lowest level and keep on integrating them in terms of a functional completeness. Like certain units need to be together to be able to integrable, so that you can integrate them. So you do that, make bigger submodules or bigger units, then integrate them and so on. So we haven't done, but in UML, if you look at the component diagrams and so on, you'll see that this kind of information become very useful here, where you give a hierarchical specification for how you have partitioned your entire system design, going from the entire system and then subsystems, subsystems and so on. So you can just on that tree, you could start coming bottom up. That's kind of the approach that you take. Now, when the system is made up of large, small subsystems, but of course, this too at times could become a big bang, because you might find that, well, even to have a meaningful integration, you might need to have a number of units to be integrated together at a given point. So the other, of course, is on this same component tree diagram, you could have a top-down integration. That is, you come from top. So what you need to have, and which again becomes useful in bottom up also, is if you can have dummy units. See, your unit has a functionality. So think about the black box testing of the unit. So that has a functionality, and it has been tested through the unit has been unit tested. So it has a pretty exhaustive black box test suite, right? So what you do is that has been validated. So what you do when you integrate, you don't actually put the unit, but you put a dummy unit where for those test cases, you have the correct golden, right? So what you're saying that, well, given this we have already tested, So let's see, if we just assume that this unit is correct, then how does other units work? And then try to go that, so that you can kind of minimize the complexity of testing, and do that in bottom up way as well as in top down way. And in reality, what will often happen is you will do a mix. That is, you will I mean, you cannot in a complex system, coming from top down to every detail unit, not feasible. Going from every detail unit to the top is not feasible. So you will, on the component diagram, you will decide on a one or two subsystem levels, so that you come from top to that subsystem level, where one subsystem is being tested, others are dummy subsystems, which are just giving correct answers all the time they require. Similarly, for every subsystem, you come bottom up by taking the smaller systems inside and get that tested, and finally you go big bang. So both ways have issues, of course, because if you are doing top down, then testing has to wait till all top level modules are coded and unit tested. So that is where this concept of skeleton or concept of dummy modules come very handy. And often there would be maybe smaller sub teams which just writes the dummy module, which does not have the actual logic, but it has a paradigm to decide these are the inputs and these are the known outputs, how to make sure that on an input you give a correct output. That's it, in a very brute force manner. And the similar thing will happen if you want to do bottom up, because then the testing can start only after all bottom level modules are ready. I mean, both ways you have issues. So kind of, you have to do a hybrid and use these dummy modules in between. Now, let us assume that the system has been unit tested, it has been integrated, and therefore your software is ready. And then you typically have what is called the system testing. Everything is ready. Does that mean that you can give it to the customer? The answer is no. Your business will go, total south if you do that. So you go through three very typical phases of system level testing. One is called an alpha testing. These are accepted terms in the industry. So this you can do when all functionality has been implemented. So there's nothing incomplete in that software, and at least to the extent that you have committed. And a reasonable testing has been done, which means that, if it has a regression clean, it is good. But more often in alpha test, what you'll have that you will have regression pass for most of the selected, critical test cases, but there could be quite a few, which do not pass still. Maybe some have been analyzed, some have not been analyzed. So you just kind of know them as exceptions. And the key part of alpha testing or alpha software is alpha releases. The testing is carried out by the test team within the company. It is still within the company. So you are doing it, your test QA team is doing it, your testers are doing it, but yet no real user is expected to have taken a view. So you will not very frequently hear about alpha releases. Once you pass the alpha release, that is, you have achieved, okay, all this integration, this with the exceptions, it's looks like stable. Then you go into the beta release phase or a beta testing phase of the system, where all functionality has been thoroughly tested. In alpha, everything was implemented, but may not have been thoroughly tested. In beta, you need all functionality to have been thoroughly tested. Extensive testing has been done for the entire system, a lot more than what you have done in alpha. And the regression will pass, maybe with a few exceptions now. And each one of the exceptions now is expected to be documented. So in your release note, you will document, well, these are the 5 exceptions. These are the 5 things that will not happen. The key thing is the release is made to friendly customers. And now, friendly customer, it could be non-developer internal groups, like the release is made to the HR group, the release is made to the admin group, You ask them, okay, this is a financial software, so you should be able to test it. Or in some cases, release is made to other development groups which do not know. Or you could have friendly customers. Often we used to have customers who liked to work as our beta site. Now, why will the customer want that? The reason customers want that is often that gives them a early look into what's going to come in the library, and therefore gives them a competitive edge over their competitors, right? So maybe we are providing this library to 50 customers, and 3 of them agree to be beta partners. So they agree to do the beta testing. So they will get to know about the features in the new release, how to use, what is good, and so on, much earlier than the remaining 47. So in the intervening 2-3 months that goes in the beta testing and the beta release to the final release, they would be ahead in terms of their development. So there are different reasons. Or for general purpose use software, big companies launch beta programs. So you'll often hear about beta programs from Microsoft, from Google, and so on. So this is launched. So there's a beta program. So anybody can register for it, download the beta release, test it, use it. They say use it, learn, use it. But their main intention is to tell you that, well, when you see issues, just you file them. Right? So it must include real users. That's the beta testing. Once that has got stabilized, the issues have been fixed and everything is done, then you do the acceptance testing on what is known as FCS, first customer shipment. That is time you are actually giving it to your real customer. Right? So as a company, you have gained a fair amount of confidence on the quality. Regression is either completely clean or has very rare, very well documented exceptions, which does not affect any of the critical functionality. And customer will use it now till bug fix releases and other major versions are changed. So on this FCS, the customer will perform the testing by their own team, typically called the testers or acceptance testers, and they will decide whether your system has passed all the requirements. Right. So this is the point where your validation and verification both converge, that the acceptance tester will tell whether you have built the right system and whether you have built the system right. And only when the acceptance testing happen, you get paid. Right. So it's very, very critical in that way. So this is a basic life cycle of system testing. There are more beyond this, this FCS, the first customer shipment, in terms of major, minor, and patch releases, which I'll talk about as a part of maintenance. So this is what is the basic system testing ideas. Now, usually when you test, you also generate a test summary report, which generates towards the end of the testing phase. So which talks about what kind of subsystems you have tested, what test suites you have used, how many have been done, how many are successful, how many have been unsuccessful, to the degree to which they have been unsuccessful, and so on. So there's a test report. Usually every company has a format of their own, and in that you produce, and that is what is also given to the customer for the FCS. Now, besides these tests, there could be a wide variety of tests which could be actually dependent on the software that you are building, depending on what are the, for example, maybe performance testing you will do possibly for all software, checking how are you doing on time, peak memory, and so on. You may want to make it really, your software might need real robustness. You will do endurance stress testing. So aviation software. For aviation software, this is a huge part, because no matter what exception condition, the system cannot fail. You can do volume testing, configuration testing, whether it works on all configurations, compatibility testing. You have developed it on 32-bit. Will it run on a 64-bit machine? You have developed on a little endian system. Will it run on a big endian system, and so on? What is the compatibility? Recovery testing is something which is very, very important. That well, can the system recover if there has been an error? There were on this assignment, there were a couple of questions that came up from some of you that, well, once I have an exception, the system closes. No, that's not the purpose of exception. The purpose of exception is not to find an error and close the system. You cannot do that. You cannot do that for a live system. You should be able to recover from there. That is what is recovered to a consistent state, undo certain things that may have been done. So that could be because of some internal issues, input problems, internal logic problems, or it could be due to failed power, failed network connection, and so on. For example, I mean, in late 90s, mid and late 90s, we were working for the automation of Calcutta Stock Exchange. It was getting automated, and online trading on Calcutta Stock Exchange was getting implemented. So we were supervising that. Now, one of the recovery tests that was required is while the system is in execution, it of course had multiple servers, multiple disk banks, RAIDs, and all that. The recovery testing is to the extent that if I take out one of the server board altogether physically from the system, there should be nothing happening in the system. Right. So that's the kind of recovery you want. If I take out a live disk out of maybe there are 10 disks, if I take out one live disk, nothing should happen in the system. So recovery testing is something for mission critical software. It becomes very important. Yeah. Of course, there is maintenance testing, documentation testing, usability testing. Kind of Selenium will partly help you in that. Environmental testing, others, and so on. So all these are part of system testing as well. In the remaining, I think about 9-10 slides. For each one of them, I have given a slide which talks a little bit more about it, but we'll not go through that. Those are more routine. You can just go through and understand. So I will stop here at this point. So is there any question? No? Okay, then. So just to update you that in the test yesterday there was a doubt about one question, answer of one question. So we have checked, and I'm sorry to say that it was an oversight. The correct solution was not put. A wrong solution was put, and that is the reason that some of you had the mismatch. So we are reviewing the answers given by each one of you, and we'll correct that for each one of you, and the marks therefore for some of you will increase and for some of you will decrease, because if by mistake you have given it that way, then it might decrease also. Anyway, so that will be done, and we'll send out an information on this. Okay, then. Thank you very much. Tomorrow is a holiday for I think Good Friday. So we will not have a class tomorrow. We'll meet again next week.